Hi students, welcome to Alpha C learning program Mathematics. In previous session we have discussed about focal chord some problems. Now let us discuss about here chord equation with middle point. Okay. So actually chord will be the same only, but under different data we are going to find equations. Now earlier we found chord equation when end points are given, and particularly to the parabola y square is 4ax we have taken at t1 and t2, and thereby we have derived the equation as y into t1 plus t2 is equal to, okay, y into t1 plus t2 equal to 2 into x plus a t1 t2. Okay, so we have derived this equation when the equation of parabola given as y square equal to 4ax parametric form. Otherwise, what is our standard form for any curve? Understand? That means it can be conic, we can say simply, and it is S1 is equal to how much here? This is S1 plus S2 equal to S12. So this is equation of chord we have done when end points are given. Okay. Now in this problem the data is different. That means when middle point is given, this is exactly middle point of the chord. Now equation of curve is given as here S equal to 0. This is equation of curve is given, and x1 comma y1 is middle point of the chord given. Okay, this is midpoint of chord AB given. Then what about here? Equation of the chord. Okay, equation of chord we require. Then for any conic we can apply the formula as here S1 equal to S11. Already you have observed in circle also same kind of formula. So how we can derive this value here? You can derive this one as, suppose for example, yes, if you consider y square equal to 4ax, then this point is here at1 square 2at1 we can write, and this point as here at2 square 2at2 we can write, and thereby we can write here x1 is nothing but a into t1 square plus t2 square by 2, and y1 is nothing but 2at1 plus 2at2 divided by 2. Then those values if you substitute here, clearly you can get the equation as S1 equal to S11. So the equation is nothing but here, equation of chord is nothing but S1 is equal to how much here? S11. So now we got this kind of formula, and then again we can obtain here length. Earlier also we found here length of AB, and numerical problems of course not necessary any formula, directly you can make use of here distance formula. Whereas whenever it is in parametric form, conceptual one, then you can make use of the formula. Already we have done AB length of the chord is nothing but how much we got? It is A into mod of T1 minus T2 into under root of T1 plus T2 whole square plus 4. So this is our formula earlier we have done. Now again same kind of formula you can derive using middle point x1 comma y1. That means here just now we have discussed this y1 is nothing but here at1 plus at2, and x1 is nothing but at1 square plus at2 square by 2, and those values if you substitute here, simply we can obtain formula in this way. And you got here minus S11. Minus S11 means it is not negative, as the point is lying inside, therefore here S11 already less than 0, because the point is inside, S11 less than 0, hence minus S11 is here greater than 0. So nothing to worry about this value, it is already positive. And this value sum of square anyhow positive. So this one is here length of chord AB when middle point is given to the curve. What is the curve here? Y square equal to 4ax. This one, because we are using y1 square plus 4a square, therefore this is for y square equal to 4ax. This kind of formula you can observe. Whereas S1 is S11, this formula you can make use for any kind of conic including circle. Understand? Circle, even in pair of lines also, if at all we want to obtain here, this is the middle point suppose to the opposite side, then these two lines can be here. These two lines given as here S equal to 0, the second degree equation. Okay, the second degree equation S equal to 0 given by these two, and if this is the middle point of the portion between these lines, then equation of this side can be obtained obtained by again same kind of formula, that is S1 equal to S11. So now here this is the equation we got, chord with middle point. Okay, let's have a glance on these problems on basing on chord with middle point. Now first one is find locus of midpoints of chords of parabola. Y square is 4ax which touch the circle. Okay, which touch the circle, x square plus y square is a square. Now here the parabola is given here, y square is 4ax equation, and now here this parabola, what is the chord they are asking? Chord with middle point. Now whichever locus they ask here, locus of they are asking about middle points. Whichever locus they ask, usually we consider that particular point as x1 comma y1, particularly p of x1 y1. So now we want to find here locus of the point x1 y1. Now how is this point? Actually it is midpoint of chord, suppose AB. Okay, now the equation is here, y square is 4ax. Now they are telling that this chord is touching a circle. Okay, first let us find here what is equation of chord, and we know it is nothing but S1 is S11, and to this parabola it is y1 minus 2a into x plus x1 and is equal to S11 means y1 square minus 4a x1. Okay, and now if I write this value, it is y1 and minus 2ax and minus 2ax1 here. Therefore if I write that side, it is y1 square again plus 2ax1, so minus 2ax1. So finally the equation is nothing but 2ax, okay, minus y1, and next it is nothing but plus y1 square minus 2ax1 is equal to 0. So this is equation of chord we got with middle point x1 y1. Now they said here this chord is touching which one here? A circle. That means this line touches a circle. A circle, what is the circle here? X square plus y square is a square. Then we can make use of the condition d equal to r, that is perpendicular distance from center of circle onto this line is equal to radius. Or else this formula also we can apply here, that is Lx plus my plus n equal to 0. Touches the circle here, x square plus y square is r square or a square. Then the formula is a square into L square plus m square is equal to how much? N square. This formula you can apply, or else directly you can make use of the condition, that is d equal to r. Then if I write this condition here, it is a square and into L square means here 4a square and plus m square, that is y1 square, and equal to this side n square, implies it is y1 square minus 2ax1 whole square. So this is our value, and if you simplify, this is our required equation of locus. Now how is actually this is a chord with middle point x1 y1. They said here this is touching a circle. Now the circle is actually here x square plus y square is a square, implies it is here center is here vertex, and now this one here this circle, this chord is touching the circle. Again if you take another chord, again the middle point if you take, then that chord also here touches this one. Then the condition they are asking actually the locus of all such middle points of chords. So we have taken one of the chords here, that is S1 is S11, and we have simplified here this minus 2ax1. We sent that side, it is minus 2ax1. Then these two values also we have taken the other side. Now it is of the form Lx plus my plus n is 0, is touching a circle. Now this is our condition, and here we have substituted, that is a square, radius square is 4a square L square plus this is m square equal to n square. Now which is true for any point on the locus, hence final equation we can obtain here, that is nothing but just we are removing the suffix, that is x1 y1, and thereby we can write it as y square plus this one is how much? 4a square, y square plus 4a square into a square is equal to this side we write y square minus 2ax whole square. So this one is here our equation of required locus. Okay, and next one, let us read here second problem. What is the second problem given? Locus of midpoints of chords of parabola which pass through a fixed point h comma k, and that is also they are telling is a parabola. So that equation also they are telling a parabola. So what is the first data it is given? The data given as here, locus of middle points of chords of parabola which pass through a fixed point. That means suppose let us take here, observe here, this equation of parabola nowhere it is given. Implies now whatever the answer you are going to get, that better let us take the generalization of any kind of parabola. They didn't mention here any ways here equation of parabola, of course here they mention, but even then we can generalize this one, because locus of midpoints of chords of parabola which pass through a fixed point hk is also a parabola whose lattice rectum is. Understand? Now here even the equation is not given or given, we can make use of this concept for any kind of parabola. Now here locus of midpoints, how are they? They are all here passing through a fixed point. That means here the point hk they did not mention where it is exactly. The point can be here outside the parabola or on or inside. Suppose if I take this is the fixed point h comma k, and now I am drawing here one chord, and to this chord this is the middle point, and next again I am drawing another chord, to this chord this is the middle point. Again if you draw another chord, and here this is our middle point. Like this here if you join all these middle points, then we can obtain here another parabola. Okay, another parabola. And how is that parabola they are asking? The locus is another parabola. What is the lattice rectum? Okay, so now here the data given as here locus of midpoints of chords of parabola. So this is the middle point, this is middle point. Now all these chords are here passing through a fixed point hk. Same you can draw even when the point is inside. Suppose the point is here, this is a chord, and now here this is the middle point. Again this is the chord. Now again you can take this is the middle point, this is our hk. Okay, again another chord if I take, then this is the middle point. In this way the point even can be on the parabola also. So they didn't mention that point hk can be anywhere, but once here the point, through the point if you take number of chords, then for all of them if you take middle points, the question is what is locus of all such middle points of these chords. So let us fix here one position, and that is suppose it is p of x1 comma y1. Okay, so that is p of x1 y1. Let us fix here one position, and parabola equation already given, that is y square equal to 4ax. Then equation of chord with middle point. Okay, equation of chord with middle point x1 comma y1. This is nothing but the formula is here s1 equal to s11. So this is our equation, and now here this is our locus point. Actually one of the points we have taken as x1 y1. Now the equation is y1, it is y1 minus 2a into x plus x1 is equal to y1 square minus 4a x1. And again we are want here what is the requirement? These chords are passing through which point here? hk. So instead of x and y we substitute. Before that let us do a bit simplification. y1 minus 2ax is equal to, it is y1 square minus 2ax1. So every time you here taking the value that side like that, better you remember this one is your s1 is s11. Easy to you, 2ax here, 2ax1 this side. Now this parabola, this chord, it is passing through h comma k. So here as this chord is passing through hk, we are substituting here for x and y. Then this is k y1 and minus 2ah is equal to y1 square minus 2a x1. So now here this is nothing but here a parabola. So how is this parabola? Now let us write here, therefore locus of p of x1 comma y1 is nothing but, we remove suffix, that is y square minus 2ax is equal to ky minus 2ah, right? And now let us send here 2ax that side and these two values this side. Then what will happen here? The equation of chord is now, that means the locus is now. So the locus value we got here, it is nothing but 2ax I am sending that side. So 2ax is equal to, it is y square. Okay, so y square and minus ky, and after that it is plus 2ah. So this is the value we got, and I am dividing also here by 2a, then it is y square divided by 2a and minus k by 2a into y plus h. So this is nothing but, students, it is nothing but again an equation of parabola we got. And to this parabola, if you observe carefully, we got here the standard form as x is ly square plus my plus n. This is the standard form where axis of parabola is parallel to x-axis. So this is our standard form, and in this way we got. Then what about here? Latus rectum of this model. So you know already here in the beginning we have discussed the latus rectum is nothing but reciprocal of the second degree coefficient, that is 1 divided by mod L. So length of latus rectum is 1 by mod L. This is our value. And here what is that value here? It is 1 by 2a, implies in this problem length of latus rectum is how much? It is 2a, which is nothing but exactly how much it is? Half of length of latus rectum of given parabola. So to this latus rectum is 4a, and to the locus parabola the latus rectum we got how much? Exactly half of the value. Okay, so that is nothing but here how much? 2a. So understand, students, here the locus of midpoints of chords of parabola which pass through a fixed point. So if this is the given fixed point, and now we are finding all the locus of these middle points, we have fixed one of the middle points x1 by 1, s1 is s11 we have taken, and then the chord is passing through hk, so we substituted. After that we got completely this kind of standard form, and it is of this model. And for this one the length of latus rectum is 1 by mod L, and thereby here it is nothing but how much? 1 by 2a, so it is 2a. Okay, so exactly half of length of latus rectum of given parabola. Now let us read the third problem. What is the third problem here? Through vertex, they have changed here. Usually we are taking vertex as capital A, and now here the vertex is given as O. So through the vertex capital O, they said here two chords are drawn, that is OP and OQ. Two chords are drawn, and how are those two chords? They said the two chords are at right angle. Okay, the two chords are here at right angle to each other. Also, if locus of midpoints of chord PQ is a parabola, then what is vertex of that locus? Sometimes they ask about focus of the locus, okay, or anything, latus rectum they may ask, any value they may ask here. First of all we have to get the equation of locus. And now let us observe the diagram. It is given y square is 4ax, okay, and this is y square is 4ax parabola. And now here what is the vertex? They said O, and we know clearly it is here origin. And now what is the other data given? OP and OQ are at right angles. So OP is one chord we have taken, this is OP, and this one is here OQ, and the angle between them is exactly how much here? Right angle. Okay, and now what is our question? They are asking about here if locus of middle points of chord PQ. Understand, locus of middle points of, that means if I join these two here, suppose this is our locus, if I take R of x1 y1. Now they are telling here this locus is nothing but again a parabola. Then to that locus what about the vertex? That is our question. Now here in general how the diagram would be. Okay, now if this is our parabola, this is one set of chords you got. Now these are at right angle. Again you take another set of chords like this here, understand, and now here this one is again a right angle, and here to this one the middle point is here R, and again if I join this is the middle point of the chord. Like that here, if you join all such middle points, they are telling it is a parabola. Now let us find here, students, the same model, how we can do this problem. Okay. Now earlier OP, OQ they said here, two chords they said, and this one middle point given. Implies, let us observe here equation of chord with middle point. So what is here equation of PQ under the condition here the middle point is x1 y1. Now just now we have observed it is nothing but y1, okay, minus 2ax is equal to y1 square minus 2ax1. Now we are using again a concept of homogenization here because this point is origin, okay. Now this segment PQ subtending an angle 90 degrees exactly here. Therefore you can just make use of concept of homogenization to obtain the required locus. Now here let me write this value as y1 minus 2ax divided by how much? y1 square minus 2ax1. So this is how much here? 1. For homogenization, the line always we want to write as equal to 1 by using the constant term. X variable, y variable here, and this is our constant. And now this is the equation of parabola. Therefore here y square minus 4ax and into 1 we write equal to 0. And what is that 1 value here? It is y square minus 4ax and into 1 means it is y1 minus 2ax divided by y1 square minus 2ax1 is equal to 0. Now if you simplify this equation, you obtain an equation of this model ax square plus 2hxy plus by square is equal to 0. Okay, if you simplify this entire equation. Now what is this equation actually representing? This equation is representing the combined equation of lines OP and OQ. Okay, so this equation second degree homogeneous, it is representing combined equation of OP and OQ. Now what is the relation between that combined equation here? It is nothing but OP is perpendicular to OQ. So students, observe here the beginning whatever the condition is given, OP, OQ are at right angles. This condition we are using at last, isn't it? The last step we are using. Usually this locus of middle points, whenever problems they ask, first of all we find using the concept midpoint, S1 is S11. Then always we think about the other condition in the problem. Okay, so here we did the same thing and here also we did the same thing, here also we did the same thing. So whenever any problem is given as locus of middle points, first thing is just find S1 is S11. After that think what is the given condition in the data. Okay, now this equation 1 representing what lines here? OP and OQ. So 1 is representing here lines, pair of lines OP comma OQ. Okay, so these lines it is representing. And now OP is perpendicular to OQ, implies what is our formula in pair of lines? Coefficient of x square plus coefficient of y square is 0. So what is here coefficient of x square? This is our coefficient of x square. That means it is nothing but 8a square. Okay, so it is 8a square and divided by what is the denominator? y1 square minus 2ax1. y1 square minus 2ax1. This is our coefficient of x square. And next coefficient of y square, it is only one value, that is plus 1. This is equal to 0. So our condition coefficient of x square plus coefficient of y square is equal to 0. So that concept we have applied here. Now if you take LCM, then what will happen here? 8a square and plus it is y1 square minus 2ax1 is 0. And we want to convert in standard form, then it is y1 square equal to 2ax1 minus 8a square. Now how much we can take common, because the question is what is the vertex. Therefore I want to take here 2a common. So if you take 2a common, then this is x1 minus 4a. Okay. So now we got completely a parabola equation. Therefore locus is nothing but, what is the locus here? Y square equal to 2a into x minus 4a. Now to this parabola, students, what about here? Vertex. The vertex is nothing but 4a comma 0. Therefore to this parabola, the vertex is nothing but how much? 4a comma 0. They may ask any value. So that means what is the focus of the locus or latest rectum of the locus? Any value they may ask. Once you know the standard form, you can write each of those values. Okay. Let's discuss, students, position of a line with respect to a parabola. Earlier we have discussed position of a point with respect to a parabola. Now whatever concepts you have done already in circles, here also same thing. Nothing is new, only equation, values, etc. they are different. Now observe, students, whenever you have taken a circle and if this is a line, simply you can make use of here the concept of d equal to r, d less than r, d greater than r by using perpendicular distance from center onto the line and radius of the circle. Okay. But now here we can't make use of that kind of concept, because what is the problem here? First of all, a parabola is not having a center. At the same time, radius and all we are not going to define here. That's why here we approach a new method, but that new method is applicable for even circle also. Not only circle, any second degree equation if you take, we can make use of that particular procedure. So what is that particular procedure here? Let us observe here, students, a line. It is y equal to mx plus c. First of all, I am taking. So y is mx plus c if the line, and the curve you take here, that is y square equal to 4ax standard form. So we are using standard form of the parabola. Now this is a second degree curve and it is a first degree. Whenever you want to know about the position of line, here just substitute this value in this one. That means you can get here quadratic in x or quadratic in y. Already it is a quadratic in y, therefore let us substitute here x value. That is x value, how much we can put here? Y square is equal to 4a into, it is y minus c divided by m. So this value we substituted here. That implies if you do cross multiplication, my square and minus 4ay and plus 4ac equal to 0. Therefore you got exactly a quadratic in y, or you can get here quadratic even in x also by writing this as here mx plus c whole square. Anyways you can use. Now here let us take the discriminant. Okay, what is the discriminant value? B square minus 4ac. So here it is 16a square minus it is 16, 4 into 4ac, so 16 acm. Okay, so this is our value, and let me take here 16a common, then it is a minus cm. Okay students, so now this is our discriminant value. And once you got discriminant value, you know quadratic equations concept very well. That is, whenever any quadratic equation is having two distinct real roots, okay, two distinct real roots, then the discriminant value is here strictly greater than 0. That means if this is our parabola and the line is coming exactly in two distinct real values, so these are, suppose y is having two distinct real roots, correspondingly x value from here or here also you can get exactly two distinct values. Okay, therefore you can get here these are two different points, hence we can say whenever discriminant is greater than 0, the line intersects the parabola. Okay, the line intersects the parabola. In what case we can say here a anyhow positive every time for this kind of parabola. Therefore here this implies a minus cm is greater than 0. That implies a greater than cm. Okay, so whenever a is greater than cm, or in bracket if I write, when you got delta greater than 0, discriminant greater than 0, you can observe here this line is intersecting the curve exactly in two distinct points. Okay, so to the parabola y square is 4ax, when this is the given line, then this is our condition. And next one is, suppose if you take delta equal to 0, okay, discriminant is equal to 0, then what will happen here? In this case, this is a minus cm is 0. Okay, now what is the condition that discriminant is 0? The quadratic equation will have two equal roots. Okay, quadratic equation is having two equal roots under this condition. That means here the curve and the line, if I observe, this is exactly touching at this point. So that is our equal root value. Okay, so a minus cm is equal to 0 means here the line is becoming here a tangent. So here delta is 0, that implies a equal to condition is how much here? Cm. And what about here? Point of contact also you can get. What is that point of contact here? Here you got a equal to cm, and a is cm implies in the parabola m equal to, that means in the line equation you substitute this m value as how much here? A by c. Okay, so this value or c equal to, you substitute a by m. So if you substitute the value here, you can obtain clearly the point of contact also. So now here this is the condition we got for the line. We call this line as here tangent to the parabola. And what is the leftover value? Discriminant is less than 0. So what is the meaning of discriminant less than 0? Implies the equation has no real root. Okay, so the equation has no real root. What is the meaning here? If this is our parabola, the line is neither intersecting nor touching the curve. That implies under this condition we can clearly a is less than cm. Okay, so here a less than cm, then we can say the line neither intersects nor touches the curve. So this one is, students, position of a line with respect to a parabola. So in case of circle, we observed simply d equal to r, d less than r, d greater than r, whereas here we are using the concept of here discriminant, and this one actually the same concept you can apply for even circle, any kind of second degree equation. That means here parabola, ellipse, hyperbola, simply you can make use of here this kind of condition. Okay, so one of the important models, that is position of line with respect to a parabola.